Okay, I would like to introduce you to Frédéric Charon from Faurecia. It's an OEM supplier. Time for you, Frédéric, to turn on your camera and your microphone. So Frédéric is a director for the technology, group technology director at Faurecia. And I would like to introduce you as well to Arthur Leroux from Enogia, which is a startup. You're going to speak all together. But first, Frédéric, I would like to know, how is Faurecia organized for innovation?
No, I can't tell you. I can't tell you because we just have 1.5 hours, so it's a bit short for that. Besides the fun, that's you know, see, Faurecia is an automotive supplier. Let's say historically settled in Franche-Comté, because we are here one of our major research centers dedicated to hydrogen. Let's say quite close from Belfort. We are just here. And the player. So the organization of innovation in large corporates. So I would say, as any company, we get our organization, innovation organization. But what I'd like to underline is how we moved in the past year due to the complete turnover of the automotive industry. Definitely, new technologies and new systems were coming to the automotive industry, and the automotive companies are big monsters, extremely well structured, but a bit stiff. And so they are able to churn out a lot of things, but are not very flexible. So we had to do something else and extend our innovation networks to other players, external players with whom we wanted to collaborate. And typically, we have expanded since now more than 15 years, an organization dedicated to startup scouting, but also an organization for years and much more longer than that, connection with the academics, with the research centers, and also in terms of purchasing, leading a very, let's say, balanced organization and relation with small companies that are also a very large source of innovation for us. So it's a multi-span activity in terms of innovations that we have developed.
Thank you. I would like to introduce you to Arthur Leroux. So Enogia is the small turbine company. Am I right? Turn on your microphone, please.
Sorry. Yes, exactly. It's right. We are a small company, a startup company, which I founded with two fellow engineers, friends, which I met in engineering school many years ago, Antonin Pochet and Nicolas Goubet. And 10 years ago, we decided to start a company which aim was to transform heat into electricity. And by working on the heat to electricity conversion by means of a thermodynamical cycle called the organic mountain cycle, we quickly discovered that the key barrier to unlock the small-scale conversion of heat to electricity was, of course, the turbine expander. And therefore, we worked for many years on engineering turbine expanders and bringing them to the market. First, on stationary application scales, like for making use of waste heat of larger engines, such as gensets, like you can find in anaerobic digestion waste sectors. And we developed the company commercially on these devices. But as well, through a partnership with IFP Énergie Nouvelle, we worked on miniaturizing this technology so that it could be used on vehicles. Actually, it first started with a research project funded by ANR with Alstom Transport, and the goal was to make it small enough to be incorporated into train engines. And then we got to meet Faurecia, especially people at the Research and Development Center at Bavent. And of course, there was a strong mutual interest. about how we could miniaturize the stochastic technology on their side, and on our side, how we could bring it to a much larger market. So this is how the story begins.
Okay, so now we're going to tell another story, how you have worked together and made an astonishing discovery. So, Frédéric, I'll let you explain.
Yes, it was the beginning of the story with Enogia, and Arthur stopped where the whole story flopped, because we decided to cease doing the job. So we, at this point, we have also taken a share into Enogia, minority share, but we had sealed a partnership, and we decided to stop the project because the math were not running in terms of energy recovery in vehicles. So this is a failure. Not quite, because having a connection with a company like Enogia, we learn to know the people, learn to know their technologies, and when some time afterwards we focus on hydrogen, we had an issue with the compressor. You know that in fuel cell, you need to have air compressors that will bring the fuel cell under pressure, a couple of bars. And this compressor is not something you will find, let's say, on the open market, because he has very specific topics. In a few words, let's say variable pressure, volume, but also one that is absolutely key for the turbine, for the fuel cells, that it needs to be absolutely clean, not release any kind of dirt inside the fuel cell, because the fuel cell must be absolutely clean inside. A normal compressor would have brought pollutant inside. So we needed something special, and we turned to Enogia to see if they could do something for us. And afterwards, the technology, and because we knew the knowledge of the people, we knew the core of the technology, and so we went into a development. But Arthur, you can, I think, give more details on that.
Yeah, it's very interesting because, frankly speaking, hydrogen, as a small company manager, I was really focused into our core business. Of course, when you run 25, 30, 40 people now company, you cannot afford to look at every market and every possible applications, because then you get distracted, and the performance, the economical performance is not so good. And so sometimes my shareholders tell me, focus on your core business. And therefore, the hydrogen market was something I was following through some success stories of friends, of nice startup companies, but it was definitely not a market Enogia was involved into. And I remember having this discussion with Pierre-Emmanuel Casanova a few years ago. It was so interesting to discover the strength and the fast-growing characteristics of this hydrogen market. Yet we didn't see how this would impact us as a company. And then Faurecia came with this very strong intent to go in this market. And this was something impressive to us, because we saw such a big company focusing a lot of effort into going into the hydrogen market and discussing with us about how we could turn our turbine into a compressor. And basically, when you do turbo machinery, a turbine is basically a compressor which rotates in the other direction. It's not so different in what regards engineering skills. And therefore, we started to look into this compressor problem, this compressor issue. It must be smaller, it must be tighter, it must be cleaner than what is available in the market. You need to run a lot of cycles, you need to guarantee lifetime, you need to focus on being something which can be produced at large scale and low cost. And this was very interesting to us, because all that we developed into looking into the small scale ORC for car exhaust, it seems that a lot of ideas we had in this work could be taken from a small turbine to making small compressors. And yeah, it was very interesting. And right now we've moved forward. We've done a few prototypes. We've signed a few contracts with some key players in this market. And it's now becoming a much more important thing to our company. And in the years to come, I think it would become a second pillar of what we will build our growth on.
Okay, thank you. Just maybe one word from Pierre-Emmanuel Casanova, because you mentioned him. So he's a CEO from HySiLabs, and he would like to give us a word about what we call an unexpected discovery, because this is the start of the story as well for HySiLabs. If Pierre-Emmanuel can turn on his camera and microphone as well. It's up to you.
Yeah, thank you. And thank you, Arthur. Thank you, Frédéric, also for the intro. So yeah, when we decided to create the company based on an unexpected chemical reaction that we have in a public university in the south of France, at Aix-Marseille University. So yeah, basically this the technology that we developed, which is a liquid carrier, but I'm pretty sure we will have more time to discuss
Yes,
about that,
absolutely.
is based on an unexpected chemical reaction that occurs in a chemistry team hands. So yeah, everything is about creating something that nobody expected to create, and when you have this kind of thing in hands, it's very interesting because there is such a novelty, such innovation based from this unexpected chemical reaction that we found every day.
Thank you for this, Pierre-Emmanuel. I have a question for both of you, Frédéric and Arthur. Question coming from the audience. What materials are used for the air compressor, and what are the compression rates? Arthur, maybe can give the answer.
Well, in what regards to materials, it's fairly classic materials that are used. Air compressors use mostly aluminum as housing materials and materials for the wheels because the temperatures and pressures are relatively low, and the compression rates differ from the customers. But mostly, most of the projects are in 2 to 4 compression ratio range, and I'd say even more of the projects are in the 2 to 3 compression ratio rate. The pressure is relatively low at the outlet of the compressor. Still, it doesn't mean it's an easy to engineer product, because you have many other constraints such as weight, capacity, cycling durability, lifetime durability, and cleanliness at the exhaust of the compressor.
Okay, I would like to introduce you to Vaitea Cowan from Enapter. It's a startup based in Germany. And as a startup, maybe you have a reaction about this story of cooperation between a big group and a young startup.
Absolutely, thanks for having me. And yeah, what a fascinating story it is. I think it's amazing that you really seized the opportunity. Both of you really seized it and saw that there was something great to be done. And I think you can really see a complementarity of skills in regards to the innovations and then the experience that Frédéric could bring with his team. So congratulations to both of you. It's needed to accelerate picking up and scaling of hydrogen.
Thank you. I would like to have 2 more reactions. I would like to ask François Aguey-Zinsou from Sydney, from the University of New South Wales in Australia, because he's very familiar with the French research. And I would like also to hear from Federico Zenith from SINTEF in Norway. But first, François, and thank you, because it's nighttime in Sydney, so thank you for being with us. So as I said, I'm very familiar with French research. What do you think of this story?
I think it's a great story, and I think Vaitea actually summarized my thought too. Sometimes, and I see that in some of the venture I'm involved in, we have a lot of people that think that's not a great idea, and then because exactly what Frédéric mentioned, you know the people, you know what they are capable of doing, then you think of them because they are the right person to help you solve the problem. And I think this is always a story of life. You never know what comes around the corner.
Okay. Federico, so you're working for the SINTEF, which is a research center based in Norway. Same question. What do you think of this cooperation?
Well, it's a very good pattern. We see this kind of pattern all the time. I mostly work in European projects, and it's pretty normal. We have one or more big companies or some small companies, and usually this cooperation is always fruitful. What you have, on one hand, you have the agility of a small company, the short decision chains, and on the other hand, the experience and the means of large companies. So it's always a good mix.
Okay, thank you for all this. Because time is running fast, we are going to carry on now with ENGIE. You know, ENGIE, the energy company. So we are going to hear from Secil Torun and Alessandra BARBA. So let me please introduce you to Secil Torun, which is a team leader from the lab hydrogen at the ENGIE Lab CRIGEN, which is a corporate R&D center. Am I right?
Perfectly right, Laurent. Thanks for this kind of introduction. So yes, let me first introduce CRIGEN, Center of Research and Innovation for Gas and New Energies. This is a corporate R&D center, not only one within ENGIE, but the main one. We are a little bit less than 200 people, split in 9 teams, and among them 3 dedicated to new gases, liquefaction, biomass, biogas, and waste, which is led by Alessandra, who will speak afterwards, and yes, hydrogen.
Turn on the camera so that we can see her and say hello to Alessandra as well. Welcome. Oh, please keep going, Secil.
Yes, and within CRIGEN, we are fully dedicated to bring technologies into maturity and to prepare the zero carbon transition. And this is really very important for us.
And so your position on the whole value chain at the CRIGEN.
Yes, coming back to hydrogen, my team is fully involved in developing the technologies, overall the hydrogen chain, from production to the different uses, going through transport and storage. And our main missions are first to lower the cost of the hydrogen chain. This is a huge challenge. The other one is to enable the development of hydrogen in different markets for industrials, for territories, and for mobility, for instance. We are identifying and developing this new technology. And last but not least, very important for ENGIE, we have many assets on natural gas, and we have to find ways to valorize them. So we are developing different projects of injection of hydrogen into the grid and producing synthetic natural gas, for instance, not so far from in the Bourgogne-Franche-Comté area in Lyon with the ICONE project.
Yes, so you mentioned injection of gas in the grid, and grid, by the way, is the name of a project led by ENGIE. It's in the north of France. If you can tell us a few words about this.
Yes, for sure. Not surprisingly, innovation is not only in the E of CRIGEN, but really in our DNA. We started a grid project in 2014, well before all these developments that we see today. And this was a very important step to go through and to understand what could be the next step for green gases. And in green project, we proved that we could inject and operate safely up to 20% of hydrogen into natural gas distribution grid. This hydrogen natural gas blend was used in more than 100 households and burned into a heater of a health center. And this is really a success that we're looking for to develop in other areas beside Dunkerque.
Okay, so Alessandra, you're the team leader of the Biogas, Biomass and Waste Lab in this same ENGIE Lab CRIGEN. So you're going to introduce us to a project called Gaia. It's about how to turn biomass to hydrogen.
Yeah, thank you, Laurent, for the introduction. Well, you heard from what Secil said that, of course, in CRIGEN, we are working all along the value chain of hydrogen, and it's important for us to find new ways of producing hydrogen. And we have a platform, a semi-industrial platform, which was built during the Gaia project. Initially, the Gaia project, which was launched in 2010 with 11 partners from industrial, institutional and academic world, aimed to demonstrate the technique technical, economic, and environmental feasibility of producing biomethane. Initially, it was biomethane who was targeted. And on the platform, we build an integrated system where you have a pyrogasification brick, a syngas cleaning step, and a methanation process, which is an in-house methanation process, which was developed for this project. And it's built as a semi-industrial scale, because we really need, we thought there is a need also to help to facilitate the scale up towards an industrial scale afterwards. So that's why it's quite a big platform which was built. And now, after producing this biomethane from biomass, after producing also a synthetic methane from waste such as refuse-derived fuel, we saw that there is also an opportunity with the same equipment to diversify the energies that can be produced, meaning that with the same equipment we can produce also hydrogen. We have 2 years ago launched a thesis with our longtime partner in Toulouse, academic partner, the Laboratoire de Génie Chimique in Toulouse, a thesis aiming to study how to enrich the hydrogen content in syngas through pyrogasification by applying a chemical looping concept and optimizing the technical operating conditions. The aim afterwards is to demonstrate it on the Gaia platform, but we know that there are also to address the challenge of lowering production costs, there is also a need to study the downstream bricks, I would say, so the syngas or the syngas cleaning step, and also the water gas shift reactors. So for that, we know that one of the strengths of innovation is, of course, to have experimental demonstration, but also to gather excellence partners in a common goal. And that is why we are also looking to launch a new R&D project on this topic with partners who can bring their expertise on syngas cleaning to purify and have a better quality of hydrogen in the end, development of catalysts, for instance, and also, I might say, regarding CO2 capture, and not only capture, but usage also. Because when you are developing a new pathway, and we know that hydrogen coming from pyrogasification is not yet developed as electrolysis, for instance, but we are aware that we need to address the economic constraint, but also the environmental constraint, and develop a sustainable pathway.
Okay, I would like to ask Vaitea Cowan from Enapter and Arthur Leroux from Enogia maybe to react, because we have here an example of hydrogen being produced with biomass and waste. Although you are focused on electrolysis with green electricity, Vaitea, what do you think of that? Does it make sense to take everything to make hydrogen?
You know, we're going to need a lot of hydrogen, right, in our future, and especially green hydrogen. So I think any technology that actually gets us there to provide enough hydrogen is a step in the right direction. And there's a lot of waste. We're creating a lot of waste. So if we can use waste to create hydrogen, then great. But ultimately, it will be a question of speed and price. This is where the competition will be. And this is why we're focusing more on the AEM electrolyzers, because we know we can scale this very quickly. So.
Thank you. Arthur, please turn on your camera and come with us, because I know that your company, Enogia, has been studying methanization. So what do you think of this R&D project at ENGIE?
Actually, we are supplying devices in all the bioenergy sectors, in the applications of our standard products. They fit well into these operations of converting biomass into something else, namely hydrogen or electricity, because there are always some wasted streams in these applications. But what is more interesting is as Vaitea said, we need more and more clean hydrogen for enabling the sector to go forward this hydrogen revolution, and therefore we are very keen to support any kind of technology which will allow to benefit from more hydrogen in a greener way, because in the end this will be an opportunity for more vehicles to use this hydrogen, and of course more vehicles mean more fuel cells and means more compressors. So I'm not totally I'm in what we call a conflict of interest in here.
Okay, I would like now to hear from Olivier Dhez from HRS, which is Hydrogen Refueling Solutions. So you're the Director for Business Development and Marketing, Olivier. So we hear a lot about green hydrogen, but we can produce hydrogen differently from biomass, for instance. So does it make sense for you as a builder of H2 stations?
Yes, of course, yes. I think, as it was already mentioned, that we'll need to use a lot of hydrogen. So it can come from any source, and it will be used for any applications. I think in terms of mobility, what we care about is the quality and of the hydrogen, because it will be used in the fuel cells, and the fuel cell need to have quite high purity hydrogen. But after the production can be anyone, and we will be very kind to use any type of hydrogen in our refueling station.
Thank you, Olivier. I would like to get back now to Frédéric Charon from Faurecia. He's the voice of the automotive industry today. So, Frédéric, what do you think of that kind of production, hydrogen from biomass? Does it make sense for you?
The answer regarding hydrogen is quite simple. Everything makes sense, because we have to change our mindset. We have had we went through the century of oil, and oil is so simple because you just get it from the ground, liquid, normal pressure, incredible density of energy, normal state. So we have been, let's say, child that have been too much cherished by a product that is altogether a gift and an omen, because it's very difficult to get out of it. Okay, but what is absolutely great about hydrogen, and we heard it today, you can produce in so many ways. Clean ways, not so clean ways, and you use it in so many ways too, because you can burn it, put it in gas, put it in heaters, put it in fuel cell. So the usage is absolutely wide. And so when we talk, because that was the looming story, is it clean? Is it energy efficient? Is it cheap? No, it is not yet. But we get so many ways to improve it. And we are just at the beginning of the story, because the age of the fuel cell, for example, is more or less the same as the internal combustion engine. But it was so simple with oil. So why bother about hydrogen? But now time has come for everything we know about global heating and pollution. We are at the beginning of the story. We are producing fuel cell, but the range and the possibility of improvement is as much as if we were at the beginning of the 20th century working on internal combustion engine. We are very much at the beginning of the story, and hydrogen can be used everywhere, produced everywhere in so many ways. So that's the smallest atom in the world, but it's absolutely magic, I would say.
Okay, thank you. So time has come as well to carry on now with the Q&A session. And I'm going to call Bruno Jamet from the Cluster Vehicle of the Future. So I have read that you had one question for Secil Torun from ENGIE. It's about the injection of hydrogen in the grid for natural gas. So Bruno, if you can turn on your camera, I'll let you ask a question directly to Secil.
Yes, the first question is, in case of low gas flows, how do you ensure the homogeneous mix of H2 and natural gas?
this was one of the points which was investigated in our grid project. GRDF designed a mixed station which ensured that whatever the quantity of hydrogen injected into the flow of natural gas, it will be, I would say, well mixed to ensure a good level of hydrogen and natural gas mix.
Okay, do we have some other questions, Bruno?
Yes, another question is why producing hydrogen from waste and biomass instead of producing maybe e-fuels from electrolyzers, H2 and combination with CO2?
This is a very good question.
Alessandra, would you like to take this one?
You can start and we'll complete maybe.
Okay.
Okay, I'll start if you want, but basically within ENGIE we are looking at lots of ways. We are not thinking at either one pathway or another, and so we are looking at both ways, either producing hydrogen from biomass, but it doesn't mean that we are not interested also at studying the opportunity to produce also e-fuels from biomass. It will all depend in the end of the market and to find the right economic conditions also.
Yes, for sure. We are really, especially on the R&D center, really technology agnostic, process agnostic, and we are really looking at different business models with different technologies to produce the hydrogen, different ways to combine hydrogen with CO2, for instance, and looking on the power to X processes, but also processes coming from biomass.
Okay. Any additional questions?
Yes, two other questions about the biomass. Are there some constraints in terms of biomass type?
This is something. Sorry, this is something we are currently looking at to know how large the feedstock panel can be. So we are trying to diversify as much as possible the type of feedstock. For sure, there are some kind of limitation, and we are working in mixes to address wood chips, for instance, barks, crops, and so on, to mix it and find the optimal one.
Laurent, it depends on the time we have, but there are lots of questions.
Maybe a last question.
What about methanol fuel cells instead of hydrogen fuel cells?
From our side, we are really looking and testing all these different type of cells. So we are really involved on all the chain, not only for hydrogen, but also for the other molecules. So looking on e-fuels, we are looking on ways. We are involved in project on ammonia. We are involved in project on methanol, DME, formic acid, from the production to the usages. If I could just give an example, a very concrete one, in Dunkerque, in our C2 fuel project coordinated by us, we are producing DME, we are producing formic acid to send them as hydrogen carriers to two different markets. One is for internal combustion of engines with Volkswagen, and the other one is to be sent to fuel cells with a startup called Dhez in the port of Dunkerque to produce electric power for cold ironing. So really going through directly of these molecules to fuel cells, or reforming these hydrogen carriers into hydrogen then sent to fuel cells, are really in the heart of the different technologies and once again business models we are investigating.
Okay, thank you.